Hello everyone, this is Anamika Joshi and I'm going to discuss arithmetic coding. Arithmetic coding is a method of generating variable length codes. It is especially useful when dealing with sources with small alphabets such as binary sources and alphabets with highly skewed probabilities. And it is also a very useful approach when, for various reasons, the modeling and coding aspects of lossless compression are to be kept separate. So the key idea is, it completely bypasses the idea of replacing an input symbol with a specific code. It takes a stream of input symbols and replaces it with a single floating point number. The output of an arithmetic coding is as usual a stream of bits. We can think that there is a prefix 0 and the string represents a fractional binary number between 0 and 1. So here we consider an example wherein we have a string BCCCB and the alphabet used are A, B and C. The arithmetic coder maintains two numbers, low and high, which represents a sub-interval. Low, high of the range 0 and 1. Initially the value of low is 0 and high is 1. The range between low and high is divided between the symbols of the alphabet according to their probabilities. So here we see low is 0, high is 1. And we have the probabilities of alphabets A, B and C 1 by 3 equally for all. So herein we start. The probabilities are summed up here. From 0 it became 0.333, then 0.667 and finally it reaches 1. Now we go on to the next level. As I said, we were decoding BCCB. The first letter is B. So for this, the lower limit is 0.333 and the higher limit is 0.667. And we have the new probabilities as PA is 1 by 4, PB is 2 by 4 and PC is as 1 by 4. In the similar fashion, we'll divide the previous interval. And the next symbol, the low value will be 0.5834 and the high value will be 0.667. Now we'll divide it. And the new probabilities are PA as 1 by 5, PB is 2 by 5 and PC is 2 by 5 again. Again, by considering this interval, the next symbol is again C. We'll divide it again and the new low value we get is 0.6334 and the high value as 0.6667. And the new probabilities are 1 by 6, 2 by 6 and 3 by 6 of A, B and C respectively. Similar step is repeated for the last symbol, that is B, and we get the final interval as 0.6390 and 0.6501. So the coded number is 0.64 for the alphabet B, C, C, B. So we saw that starting from the range between 0 and 1, we restrict ourselves each time to sub-interval that codify the given symbol. And at the end, the whole sequence can be codified by any of the numbers in the final range. So here's the summary of what we did just now. So this is the final interval and the value. Now decoding. For decoding, we have a specified algorithm, and the algorithm goes like this. Initially J is 0, Lj is 0 and Hj is 0, where Lj and Hj are lower and higher limits. We calculate delta, which is the difference of Hj and Lj, and we have to find I, which is given by B minus Lj divided by delta. And in each step we'll calculate Lj plus 1 and Hj plus 1, which are the next higher and lower limits as mentioned in the algorithm. and this is repeated until all AIs have been encoded. Now we'll show you the decoding step. So here we are considering another example wherein we have the alphabets A0 to A4 with probabilities as mentioned here, and the description of the information source as shown below is transmitted by the decoder beforehand to the decoder. So the transmitted code word from arithmetic encoder is 01111000001, which corresponds to the following decimal number, which is b is equal to 0.4692, and so on. And using the formulas and steps mentioned before in the algorithm, we have an intermediate step as this, wherein we have calculated the value of LJ and HJ for the second time. Initially it's 0 and 1, and for the second time we're using the formulas, we get 0.4 and 0.6, and we continue the same step, and in the final step we get the result something like this. You can try it calculating the values and finding the results. So here's the result and the summary. So the output from the decoder is A1, A0, A3, A2 and A0. So we have decoded. Now we'll see why does it work. More bits are necessary to express a number in a smaller interval. High probability events do not decrease very much interval range, while low probability events result a much smaller next interval. The number of digits needed is proportional to the negative logarithm of the size of the interval. The arithmetic coding is nearly optimum as number of output bits, and it is capable to code very high probability events in just a fraction of bit. In practice, the algorithm is not exactly optimal because of the use of limited precision arithmetic, and because transmission requires to send a whole number of bits. Thank you for listening.